This video will be the even problems on pages 11.5 and 11.6 in our notes. So again, we are adding and subtracting radicals. So the first thing is you need to simplify all of your radicals. So take out the biggest perfect square. If you have the same number under the square root sign, like we have over here on the left, then you combine your coefficients by adding and subtracting. So if we look at number 2, the numbers under the square root match the 5, so then you just need to do the outside. 2 plus 2 gives me 4, and the square root of 5 doesn't change. It just comes along, just like it was a variable. So if this was 2x plus 2x, your answer would be 4x. So your square root acts like a variable. Number 14. 15 does have factors, 5 and 3, but neither one of those are perfect squares, so that stays. 60 does have a perfect square. It is 4, so 4 times 15. Square root, square root. Square root of 4 is 2, so we have this 6 and this 2 that are being multiplied to give us 12, square root of 15. I like to write this out just so I have it all in a row, but if you don't need to, that's fine. Remember, if there's nothing there, that means there's an invisible 1. So 1 minus 12 gives us negative 11 square root of 15. Number 6, we need to break down the 28 first. That would be 4 times 7. So square root signs around each of them. This square root becomes 2. So negative 4 times 2 is negative 8 square root of 7. Bring down the plus sign. 112 needs to be broken down. Now, if you know that 7 is under this square root, that probably means 7 is going to be under that square root. So if you take 112 divided by 7, you're going to get 16, which is a perfect square. So that's kind of a shortcut way to do it. Square root, this becomes a 4. So you have this 4 and this 4, giving us 16 square root of 7. So negative 8 plus 16 gives us positive 8 square root of 7. Number 8. The 45 would be broken into 9 times 5, square root of both. Square root of 9 is 3. So 4 times 3 gives us 12, square root of 5. Bring down the plus sign. Again, since 5 is under this square root, we're probably thinking 5 is going to be under this one. So if you do 245 divided by 5, you get 49, which is a perfect square. So square root of 49 becomes 7. 3 times 7 is 21 square root of 5. Then we need to do 12 plus 21 to give us 33 square root of 5. On the back, we get into where there are more than 2 that are being added and subtracted. So unfortunately, they won't always match. So you can't do the little trick where since 5 went into that one, it has to go in the other one for these. For 10, we have this has a 7 and this has a 7. So those are the 2 we can put together. 2 plus 4 gives me 6 square root of 7, and then this just comes down, plus 5 square root of 3 for our final answer. Number 12, all of them need to be broken down. So 8 gets broken into 4 times 2, square roots. Square root of 4 is 2. So we've got all kinds of 2's in this one. This 2 times this 2 gives me 4, square root of 2. Bring down the plus sign. 96 gets broken into 16 times 6. Again, you just need to go through that perfect square list and find what perfect square goes into 96. Square root of 16 is 4. So this 4 times this 4 gives me 16, and then the square root of 6 comes along. Bring down your minus sign. 24 gets broken into 4 times 6. Square root signs. Square root of 4 is 2, so 2 square root of 6. There was nothing out front to multiply it. So I'm just going to bring down my 4 square root of 2 since that one's on its own. These two you can put together to give us plus 14 square root of 6. It does not matter what order you have your addition and subtraction written in. All right, so if you have 14 square root of 6 first and then plus 4 square root of 2, that's totally fine. So the order that you write your addition or subtraction doesn't matter. Number 14, 10 square root of 6 is already simplified. There's no perfect squares that goes into 6, so I'm just going to bring that down. There is a perfect square that goes into 150. It's 25. So that's actually 25 times 6. Square root, square root. The square root of 25 is 5. So you have to do 18 times 5 to give us 90 square root of 6. Bring down your minus sign. 54 is 9 times 6. Square roots. Square root of 9 is 3. So 4 times 3 is 12. Square root of 6. So now these all match. They all have the square root of 6, so you just go straight across. 10 plus 90 minus 12 should give us 88 square root of 6. $16, they all look pretty good except for the 8 needs broken into 4 times 2. Square root, square root. This becomes 2, so 4 times 2 gives me 8 square root of 2. So if you need to write it all out, you can. Negative 3 square root of 6 minus 5 square root of 6 plus 8 square root of 2 plus 4 square root of 2. And maybe you don't have to write it all out, and that's great. So our first two match. That would give us negative 8 square root of 6, negative 3 minus 5, and then plus 12 square root of 2, 8 plus 4. And then our last story problem, number 18. The length and width of a rectangle is represented by those two expressions. Write an expression to represent the perimeter of the rectangle in simplest radical form. So the easiest formula to use here is perimeter is 2 times the length plus 2 times the width. So whatever dimensions they give you, it doesn't matter which one you call the length and which one you call the width. You essentially just have to double both of them. So there's two ways you could do this. What I think would be the fastest way is right off the bat, take this 2 times this 2 to give us 4 square root of 405. Plus, take this 2 times that 9 to give us 18 square root of 48. Then you don't have to worry about the formula anymore. You're just going to break down the 405 and the 48. Okay? The other way would be to break these down and then multiply by 2, which is fine also. So if I have 405, 81 is the perfect square that goes into 405. So then we have square root of 81 is 9. So 4 times 9 is 36 square root of 5. (48) gets broken into 16 times 3. Square root. Square root of 16 is 4. So I have to do 18 times 4, which gives me 72 square root of 3, and bring that plus sign down. So that is the answer for your perimeter. You can't put those two together because they have different square roots. So again, you need to simplify the square roots. If there are any that match, have the same number under the square root, those are the ones you can combine the coefficients.